pronounced it phenolpthalein. But this is an indicator for CO2. Anytime you're doing some in the lab, whenever the CO2 reaches the, usually it's 7.0, I think, in water, it'll turn the famous little pink color, phenolpthalein pink. But I remember asking my instructor what it was, and she couldn't recall off the top of her head. So what we're going to see here is a bunch of benzene rings around what would be called a lactone, because the oxygen forms another ring. The ketone and two alcohols off the end here. So we're going to use our smaller markers here. We bought a new pair of these for $1. Let's start. Let's see, maybe we can tweak this a little bit. So again, to draw the benzene ring, just draw your 6 diamonds first. 2 on the side we can connect if you want. It kind of makes the bookkeeping easier. 1 in the middle. One of those alcohols is up here. So we got double bonds. See, we're doing this to warm up because it takes a while to get warmed up. So there's a double bond. We'll use the colored pencils here. We'll see how that comes out, all right? So we're doing a benzene ring. If one gets a double, then it's a single, then you do a double. Then you do a single, then you do a double, then you do a single. So see, that worked out. We got the insides of these. See how the yellow colored pencil works on green paper. See, we're even experimenting here as we go along. It works. Okay. Now, benzene rings always are going to have that 4th bond. It's going to be a proton on there if it's not with a side group. Let's see, I want to go down, so. We're going to kind of aim this back a little now. That diamond there is going to go to, let's see if we can draw them connected to each other. The diamond. So diamond. Diamond to an oxygen. I'm going to make sure I got these coming in on the right carbon, so that one, yeah. So the oxygen gives it a 5-membered ring here. And that same carbon is going to go off and have another aromatic side constituent to it. So there's 1 diamond. We're going to try and draw 6 diamonds all connected to each other and see what happens. One, 2, 3. 6. And I see the double bonds. Already I messed it up, but I can put double bonds wherever I want as long as they're opposite. So double, single, double, single, double, single. Some alcohol on the end of this. Is that the one I drew it on there? Probably. This comes in, there's first, second, third, fourth. Good. So again, this is rough. This is why I'm doing it with you this way, because you just see how it goes. Do your diamonds. Those are the carbons. So they can't be wrong. You got 6 diamonds or 6 carbons. There's going to be a single bond in between them, so you can't get that wrong. You're halfway home right there. The double bonds are where it's going to get tricky. So if you learn and just practice. So in a benzene ring, these are all going to have 1H on the side. Unless there's a side group. So there's 2 side groups, 4 red hydrogen, 1, 2, 3, 4. Double bonds in there. See, in a benzene ring, the double bonds come out being like little yellow diamonds, yellow triangles. Usually they look like diamonds. It gets confusing. Carbons. Aquamarine pencil here. Here we had our alcohol. Go. That's a benzene ring with an alcohol on it. No big deal. Another benzene ring with an alcohol on it. No big deal. Now we're going to come down here off the ring. Now here's one of those carbons I was talking about. See here, it's got all 4 of its bonds colored in. Now in the 5-membered ring, I look around and I see right next to the oxygen, there's a double bond O. The yellow double bond. Use the crayon here, see what happens. That carbon's down, I'm going to color that in. So isn't that neat how you take your time, gain a little confidence as you go around? The double bond. So now coming 1 carbon over from the double bond starts the 3rd benzene ring. So we got pretty good at just connecting the diamonds. Let's try that again. Just 6 diamonds. We already got 2.